the perpendicular bisector
Bisector of what?
of AC.
AC, exactly. So it's good to draw perpendicular bisector, okay? Then, in the next step, can you tell me that when we have perpendicular bisectors, it's good to draw what?
When we have perpendicular bisectors.
When I told you perpendicular bisectors,
A circumcircle.
the circumcircle, exactly. So let me, if I draw the figure is this, right? It lies on perpendicular bisector, and we can draw it, right?
Yeah.
Okay. So let me draw perpendicular bisector, and in the next step, we can draw circumcircle. And look, the problem says prove that AB is tangent to circumcircle of PEM. So we can say we should prove what angle is equal to what angle.
AB is tangent to the circle of BEM.
For example, if we draw this one, this is BEM, it is tangent. So this angle should be equal to which angle?
BEC.
BEC, look, it says it should be tangent to BEM. It should be equal to BEM, right?
Yeah.
So we can call, we can call this angle is alpha. This angle is what? Is 180 minus b, right?
Yeah.
So here we should prove why alpha is equal to 180 minus b, right?
Mm-hmm.
Agreed?
Yes.
And also the problem says it is 90 plus a, right?
Yeah.
And also it says DAC is ACB, so this angle is C, right?
Yeah.
So we can draw also this one. Extend this one. So here we should prove alpha is 180 minus b. Can we? It is midpoint here, right?
Yeah.
So for example, let's call this point F. Let's use a bit angle chase. And let's also draw this. This angle is what?
Is B.
Yes. And we should prove alpha is 180 minus b, right?
Yeah, so just prove this is cyclic.
If, for example, we extend this, it means that we should prove, for example, this is cyclic, right?
Yeah.
Okay, so one way is to extend this. Another way is to, we have B here, so we can extend this one. And because it is midpoint, let me extend this like this one. If we draw a line parallel to this one, the angle is what? 93. Okay, so if we extend this, if we draw parallel to this one, we have two good things. This one, because it's equal to this one. Do you agree if we consider this one T, BE is equal to what?
TB is equal to what?
We draw this parallel. We know M is midpoint of BC. So B is equal to what?
B is equal to what? I can't hear what you're saying.
Yes,
BE.
BE. This
is BT over 2.
is equal to BT over 2 or TE. Do you agree it is equal to this because it is parallel to this one?
Yeah. Yeah.
Okay, so we can say this one is equal to this one. And we know it is alpha. And so this one is alpha. Now, because it is B and we should prove alpha is 180 minus B, we should prove what is cyclic?
DTCF.
DTCF. We should prove DTCF is cyclic, right? Agreed?
Yeah.
Okay, so Suppose this angle is beta, okay?
BDC.
Beta is 90 minus A, right?
So you're saying TB, which angle?
This angle. Let me show you. Let me maximize it. I said, let me call it 1, D1. Do you agree we should prove if D1 is equal to F1, we can prove this quadrilateral is cyclic?
Yeah.
Okay, and we know D1 is equal to what? Because it is 90 plus A, D1 is what?
90 minus A.
Exact, 90 minus. And let's call this point, for example, L. Because it is 90 minus A, this angle is what? Let me ask you this. This angle is what? It is C. It is A, so this one is what?
A minus C.
A minus. So this arc is what?
This arc is A minus C, or
2A
2A
minus
C.
Yes.
Yeah, 2A minus C.
This arc is what?
2C.
Yes. So this angle is what?
A.
Yes, A. So we want to prove F1 is 90 minus A. So we should prove angle L is what?
90 degrees.
90. Okay, so try the rest of this on your own. One or two steps. Like one step is left, okay?
Okay. Yeah.
Have you tried this one?
I tried a little more on what you said, but I couldn't do it.
Straight. We had ABC. Let's review what we did. Point D is selected inside a Q triangle such that two conditions DAC is ACB or C, this one, and BDC, this one is 90 plus A. Okay, point E is chosen on ray BD so that AE is equal to AC. So we consider this one, A is equal to AC, so it lies on perpendicular bisector, so instead we draw circle, let M be the midpoint. BC show that line AB is tangent to the circumcircle of triangle BEN. Okay, if you want to prove AB is tangent, then we should prove this angle is equal to alpha, right?
B.
Why we should say alpha is equal to 180 minus B? Because it is B and this one is 180 minus B, right?
Yeah, okay. Alpha BEC, right?
Yes, alpha
Yeah.
this, right?
Yeah.
Should be 180 minus B. So we said if we want to prove this, if we draw perpendicular to this one, and then if we draw this, and a midpoint theorem or Thales' theorem, we can say DTCF should be cyclic. Because we know this one is B, we want to prove alpha is 180 minus B. So, for proving this one is cyclic, we said we should prove this one is equal to this one, right?
Yeah.
F1 we said is what?
Is 90 minus.
We want to prove it's 90 minus, right? Why D1 is 90 minus A?
D1. Let me see. Well, BDC is 90 plus A.
This one is 90 plus A, 180 minus A is 90 minus. So we should prove F1 is 90 minus, right?
Yeah.
And because it was A, we should prove L is 90, right?
Yeah.
Okay. So it is 90 if we Because we know it is A, right? Because this one is
Mhm.
B, this one is C, so this one is A. So the only thing that we should prove is L90. So L90 is equivalent that what is perpendicular, what is parallel to what?
With parallel, well, FL perpendicular to AC, and
Call this one EN.
so EN perpendicular or EN parallel to FL or FT.
So can we prove these two are parallel to each other?
If you prove the angles NET and BTF are equal, maybe.
If you let's see what are the things that we have. This one is parallel to this one. Can we say this line, for example, is parallel to anything? Pay attention to this. What can we say about this quadrilateral?
Cyclic.
No, it's a trapezoid. Isosceles. It seems to be an isosceles trapezoid, right?
Yeah.
Okay, so I think it's better than using this. So pay attention to, and it's so much easier to find this one. Pay attention to A, B, F, C. Try to prove ABC is an isosceles trapezoid, and then use this to prove it is 90, okay, or it is parallel to this. Could you prove it and could you prove the problem?
I don't know about the problem yet, but for it being an isosceles trapezoid, so BFA is also equal to angle C because it's the same arc as AB, and then that
Exactly.
means BF and AC are parallel, and then their angles are all equal.
So we know this, let me write, this angle is C. So because it is C, why it is C? Because of this arc, and this one is C, this one is C, so this one is parallel to this one, right?
Mm-hmm.
And also we know this arc is 2C, this arc is 2C, so these two lengths are equal. So we can say AB is equal to FC, so it is an isosceles trapezoid, right?
Yeah.
Okay. So we know that if we want to prove L is 90, we should prove what is perpendicular to what?
EN perpendicular to FL perpendicular to AC.
FL is perpendicular
Or
to AC. And because we proved it is a trapezoid, we should prove what is perpendicular to what?
FL is perpendicular to FB.
Yes. So we should prove this angle is 90, right?
Yeah.
So how can we prove this angle is 90?
Mm-hmm.
One hint for this part?
Yeah.
Okay. Look, we know that En is 90, so if we can't extend this, we know En is parallel to, let's see, if we extend, let's extend this one. This angle is what?
This angle is 90.
Yes. So as I said, if we prove, for example, let's consider this point T. And we have T. So let's consider this point, for example, L, N, M. This point is P, okay?
Mhm.
Do you agree if we prove Pn is parallel to Ft, the problem will be solved?
Yeah.
Okay, one more step is left. If I tell you, like here, if I tell you next one, the problem will be solved. Want me to tell you the last part?
No.
Okay, so look like this. The next thing that I say, what is equivalent to this, is the solution of the problem. So try to see, can you prove it?
I don't see it. P and FT.
One hint.
Yeah.
Okay, so Pn is parallel to Ft, or Pe is parallel to Ft. Do you agree we know Be, or we should prove Be over Et is what over what?
BE over ET is BP over BF
Bp over Pf, right?
over, yeah,
Do you
PF.
agree if we prove this, the problem will be solved? This
Yeah.
over this is equal to this over this, right?
Yeah.
So it is B over Et is what?
1.
Exactly, 1. So if we prove Bp over Pf, or P is midpoint of Pf, the problem will be solved, right?
Yeah.
And it's so much easy to prove it. Want me to tell you why Bp over Pf is 1? Or
I'm
want to prove
trying.
it on your own?
I'll try it.
Okay.
Well, PN is the perpendicular bisector of AC. And it's
Mm-hmm.
an isosceles trapezoid. And it's an isosceles
Exactly.
trapezoid.
You can say by symmetry or any other thing. Because it is isosceles trapezoid, it is perpendicular bisector of this. So it passes also through midpoint of here, right?
Mm-hmm.
We can also prove it with, let's try to prove it with a rigorous proof. So here, for example, we have isosceles 1.8. This one 1.8. This one. Okay. And suppose it is B, it is F, it is C, it is A. Okay.
Okay.
So we know this is N. It is perpendicular bisector here, and it is P. You want to prove BP is equal to PF. One way is to say by symmetry, right? But we want to reach, for example, a rigorous proof by using, for example, congruent triangle or something like this. How can we prove this one by using, for example, congruent triangle or something like that?
Congruent triangles, you can extend AB and FC,
AB and FC are equal, yes. Then what?
and they intersect, and then you have like a bunch of triangles, and then
Yes, so exactly tell me how we can reach that BP is equal to PF.
or connect BN and FN,
You want to,
and then
you said we prove what and what? VB
well,
connect what and what?
a B to N and F to N.
Okay. So let's connect this one and this. So because you can say it is, for example, beta, it is beta because isosceles trapezoid, right?
Yeah, so those
And
are
then
the
these two
same.
triangles are congruent, right?
Yeah.
And
I
then
want to
these two
prove.
sides are equal, so it is an isosceles triangle. So when you draw altitude, it is median. Or you can say these two triangles are congruent by what criterion?
Side. What is there? Side. There's a side angle. No, there's two sides and another different angle.
Uh-huh.
Because the 90-degree angle doesn't work.
You can say hypotenuse and a side. It is
Yeah,
one.
hypotenuse
Have you
leg.
heard this?
Yeah, hypotenuse leg. Yeah.
Yes, because if you say side, angle, side, this side, but not necessarily that these two angles are equal. Or we can say Pythagorean theorem. Because this
Yeah.
squared minus this squared is this squared. Again, this squared minus this squared is this squared. So also by Pythagorean theorem, we can prove these are right.
Yeah.
Okay, usually it's better to write something like this, but also here we can say by symmetry, we can say this, or you can quickly say by two congruent triangles, and then these two congruent triangles, we can say they are equal. So we proved the problem. So this one has been proved. So this one, this one, this one, this one, this one, then it's cyclic, and always 180 minus. Okay?
Mm-hmm.